Most people think misunderstandings come from bad logic or missing checks, but they start much earlier. Before any code runs, they start in how we think about software. If you confuse software with execution, you'll expect behavior that never happens, memory that never existed, and order that was never guaranteed. These misunderstandings feel unsolvable because they aren't caused by mistakes in execution. They're caused by mistakes in mental models. Let's fix that. We casually say things like the program decides or the software remembers. That language is convenient and deeply misleading. Software doesn't decide. It doesn't remember. It doesn't act. But when we talk about software like that, our brains treat software like an active agent. And once that happens, we start assigning responsibility to the wrong thing. The system executes. Memory stores. Software only describes. When language blurs those roles, misunderstandings follow. Software cannot do this on its own, ever. This sounds obvious, but it's the single most common misunderstanding among beginners and intermediates alike. We read code as if it's already in motion. It isn't. Until execution begins, software is inert. Treating software like an actor leads directly to false expectations. If software isn't acting, what is? Execution. Execution is the only thing that causes change. Execution reads instructions, modifies memory, and produces effects. And execution exists only while it's happening. When execution stops, behavior stops. There is no lingering running state. If you remember nothing else, remember this. Execution is the actor. Software is the script. Execution is time-bound. It has a start, a sequence, and an end. Once it ends, it no longer exists. You can't inspect it afterward. You can't resume it. You can only observe what it left behind. Many bugs come from treating execution as something persistent, something that keeps going, mainly just because the software exists. That assumption is always wrong. Software does not experience time. It doesn't progress. It doesn't wait. It simply exists. The same software can be executed once, 1,000 times, or never. Each execution is a separate event. The software itself does not change, learn, or advance. More on this later. Confusing software with execution causes developers to assume continuity where none exists. State is written by execution, read by execution, and destroyed when execution ends, unless it's explicitly preserved. Software does not store state. This distinction explains why restarting a program resets behavior, and why misunderstandings appear when developers expect values to persist magically. If execution never ran, memory was never written. The system does not care about intentions or plans. It only reads memory. Expecting phantom state is one of the fastest ways to create unpredictable behavior. Another common failure happens when programs restart. Developers are surprised when behavior resets, but it shouldn't be surprising. Each execution is a clean event. Same software, new execution. If state isn't rebuilt or restored, it does not exist. Many production failures only appear after restarts because this truth was ignored. Don't blend software, execution, and memory into one mental block. That makes everything difficult. Instead, separate these concepts instinctively. This separation is not advanced knowledge, it's foundational. Without it, every new concept feels like a big job instead of mechanical. This mental model works for scripts, applications, services, and distributed systems. Software stays passive. Execution stays active. Memory holds state. If you confuse these, systems become very unpredictable, especially as they grow. If you keep them separate, complexity becomes manageable. To make this practical, use one question whenever you're confused. What actually ran? Notice how that question connects everything. If nothing ran, software stayed inert and memory stayed the same. If something ran, then you look for what changed in memory afterward. This is the opposite of guessing. You're not imagining what the system should have done. You're grounding yourself in events and evidence. Over time, this is instinctive. That is a mental move that turns confusion into clarity, even before you learn any code. Memory only makes sense once execution is clear. State only makes sense once memory is clear. Lifetimes only make sense once state is clear. This separation is the foundation for everything. This is why we teach this before coding, before syntax, before any programming language. If you don't understand the relationship, you will misread. You will stare at instructions without hope. You will stare at storage and expect it to decide. But once you have the foundation, new topics snap into place. This foundation is not trivia. It's the map.